Section 6.8 in our Math 161 Quantitative Reasoning course has a few different topics, but the topic I'd like to spend a little extra time on is graphing functions. Graphing functions can be done a number of ways, but the way that I'm going to suggest will work every time is going to be point plotting. Now, point plotting isn't always the most efficient method of graphing, so if you feel really comfortable with your graphing abilities, then you should go ahead and graph these things in the way that is the very most efficient for you. But if it's a struggle at all, let me tell you that point plotting will always work. What I mean by point plotting is we create a chart like this, an XY chart, where we start with our independent X variable. It's independent because you can choose for it to be whatever you want it to be. And then once we choose an independent variable, an X, we find a Y value that matches to that X. What we end up with when we do this is an ordered pair. It's ordered, meaning that the X must come before the Y, so our independent variable comes before our dependent variable. And it's a pair, meaning there are two pieces. When we have an ordered pair, what we're able to do is use this x-axis, and we'll plot our x value on the x-axis, and then we'll have our y-axis. We plot the y value on the y-axis. So for example, if I had the point x equals 0, y equals -2, that point would go left or right on the x-axis 0 units, and it would go up or down, in this case down because it's -2 units. So we'd end up right here at this point, and we call this point 0, -2. But by using point plotting, I can graph any function, not just this easier linear function, but I could plot any function. So let me show you the point plotting method, and then I'll go back and show you a shortcut for using the M and B. The B is the y-intercept, the M is the slope. I'll show you that method also. So here's how it works. I'm going to pick 3 points. Now I really only need 2 points. If I look at this and see that this has a flat x without an exponent, I recognize that this is a linear function, or in other words, its graph is going to be a line. So I know that I only need 2 points. I'm going to find 3 points because if I find 3 points, then it allows me to check that my answer was correct. Here's what you do with the 3 points. What you see me doing here in this black ink is I'm writing the function down without the x. And now with a different color here, I'll use this pink, I'm going to fill in the x with a 0. This is called function notation, and I'd read it f of 0. So what this means is I want to replace the x with a 0 and evaluate this. So see what value I get. 3/5 times 0 is 0. 0 minus 2 is -2. And that's where I get the -2 in the y column. So what I have here is that when x is 0, y, or f of x, is -2. Let's try the next point. Let's try a 5. When x is 5, that means I'm going to replace the x in our function with 5. F of 5 equals 3/5 of 5 minus 2. To do this arithmetic, it's 3/5 times 5 over 1. And if you are thinking ahead, you might have caught on that, oh, that's why I chose a 5. I could have chosen any variable I wanted, or any value I wanted to replace the x with. I chose 5 because 1, it's on my scale here from -10 to 10, and 2, I knew that the 5 would eliminate this denominator. But let me be clear that you could have chosen any value you wanted. But when I put a 5 in for x, I get 3/5 times 5 is 5, or 3 rather, and 3 minus 2 is positive 1. So my second ordered pair is going to be x equals 5, y equals 1. So it'll be right here. The third ordered, or the third x I'm going to choose is a -5. And when I find f of -5, that's 3 over 5 times -5, where these 5's reduce, minus 2. That's going to give us 3 times -1, or -3, minus 2 equals -5. So when x is -5, y is -5. So on the x-axis, I'm going to move -5, so that's 5 to the left. And I'm going to, on the y-axis, move -5, so that's 5 down. It looks like I'd come to this point right here. This is the point -5, -5. You see that I have 3 points, and they all fall on one line, so that verifies that I probably graphed this, or probably found those points correctly. So now I can use a ruler or other straight edge to draw in my line. And that's it. That's our first example. There is another way to do this, and I want to make sure that you see this nice, easy way to do this. It may be easy for you, and if you've been doing algebra recently, it's likely that this will be easy. But if it's been a while since you've done algebra, then don't worry about this shortcut. Just focus on point plotting. But for those students who are here listening now who want the shortcut, here it is. We have an M and a B, where B is the y-intercept. So if you recall, you start it on the y-axis at -2, and then a slope of 3 over 5, or an M of 3 over 5, means that from this point I move up 3 and right 5, and you see that I'd end on this point. And notice that if I were to connect those 2 points, I'd get the same line. So you are welcome to use the slope-intercept method of graphing. Don't feel that you must do the plotting points. This next example is another good example, and this one, because it's an x squared, this function has a special name. It's called a quadratic, and when I graph a quadratic, I'm going to get a parabola. Looks something like this. It could open downward also, so maybe like this. But I know it's helpful if I at least have in mind, in general, what I should expect it to look like. And the indication of what I should expect the graph to look like is right here, what I've highlighted in pink, the x squared. That indicates to me that probably the, well, not probably, I'm sorry, that certainly, because the x squared is, the 2 is the highest degree. There's no x with an exponent bigger than 2. This x squared tells me it will be a parabola because it's a quadratic equation. I could go back to the point plotting again. The problem with point plotting is that, sure, a 0 is easy. I can replace the x with 0, and that was easy enough to get a 5. So I could plot this point 0, 5. But the problem is I don't know how many points I'm going to need. I have to just keep plotting point after point until I finally get enough points that I can see it both rising and falling. What I mean is, for example, if I got these points, I still don't know for sure where it stops dropping. Once I know for sure where the bottom point is, or if it's a downward parabola where the top point is, then I could use the symmetry, because a parabola has symmetry right down the middle, and then I could know that it looks like this. But it's really difficult to use point plotting for a parabola, just because you do have to keep plotting points until you get enough. But I want to say to you, if you feel like this is a challenge, if you have a little bit of algebra phobia in you, just use this point plotting method and it will work. It's just that you may need to fill the chart and keep going. Do enough until you really know for certain what the shape looks like and where the bottom point is. But let me give you a little shortcut just in case you're feeling a little bit more confident and you say, I don't really want to fill a whole chart calculating so many points. This little shortcut has to do with finding the vertex. Now the vertex is that point in the parabola where it changes from going upward and to the left and to the right. So it's the bottom point, or it's the place where it changes going downward, left, and right. So it's the point where it switches over, like it's going down and now it's going up, or it's going up and now it's going down. That vertex is very easily found with a formula. The x coordinate is x equals the opposite of b over 2a. And in our equation here, if you have it in order where we've got the highest exponent, the x squared term first, and then the x term, and then the constant, then the first coefficient, that's a 2, is what we'd refer to as A. The second coefficient, that's a 4 in this case, B. And that's all you need to know. Now, just for future reference, if you ever need it, that constant, the 5 in this case, would be C. But for x equals the opposite of b over 2a, we don't need that. So for our x equals the opposite of b over 2a, we get negative 4 over 2 times 2, or negative 4 over 4, which is negative 1. So I know that the vertex happens when x is equal to negative 1. So what that tells me is I want to certainly find f of negative 1. I want to be sure that that negative 1 is one of the variables, or I'm sorry, one of the values I use to replace the variable x. Let's look at what happens here when we replace this x with a negative 1. Be careful with your negative here, because when I square the negative 1, I get a positive 1. So this is going to be 2 times 1 plus 4 times negative 1. That's going to be negative 4 plus 5. Or in other words, 2 minus 4 plus 5. 5 plus 2 is 7. 7 minus 4 is 3. So it looks like this point will be negative 1, 3, which is right here. X equals negative 1, y equals positive 3. Now here's the catch with this. If I know that this is my vertex, then what I know is that we're symmetric on both sides of the vertex. You could think of this green line, which isn't actually part of the graph of the function, but you can picture this green line as a axis, as a symmetry line. We call it the axis of symmetry. And what happens is if I have this point here at 0, 5, then I know I also have a point over here. I don't want to move my graph. I know that I have a point over here to the left of the axis of symmetry. So I could plot this point also. The reason I can plot this second point is by recognizing that we're symmetrical on each side of this axis of symmetry. And that gives me enough to graph my parabola. So that's one way we could graph the parabola. Now, again, if you want to do point plotting, you could fill the chart and you might get enough points, but make sure that you keep plotting points until you certainly know where the parabola turns around. So eventually you really do need to find this vertex, either using this formula, the opposite of b over 2a, or by just stumbling on it when you do enough points. But that's how we can graph a quadratic function. Let's graph one more. This one is an exponential function. And when I do, for this one, I'm going to use the points 3, 2, 1, 0, 1, 2, and 3. So I'm going to find f of each of these. 2, 3, 4, 5. So f of 3 means 2 cubed, which is 8. F of 2 means 2 squared, because I replace this x with 2. So I get 4. F of 1 means 2 to the 1 or 2. F of 0. This one, you could put it in your calculator if you've forgotten, but you might have just memorized. You might just know that anything to the 0 exponent is 1. So 2 to the 0, by definition of a 0 exponent, is 1. F of negative 1. Do you remember how to do this with a negative exponent? You write it as a reciprocal. So it's 1 over 2 to the 1, or just 1/2. F of negative 2 means 2 to the negative 2. So that's 1 over 2 squared, which is 1/4. F of negative 3 is 2 to the negative 3, which is 1 over 2 cubed. If you're wondering, wait, how did I get from 2 to the negative 3 to 1 over 2 cubed? It's simply exponent rule. I say simply. I don't say that to imply that it's simple, but by saying it's just by a definition. By the definition of what a negative exponent means, when we have a negative exponent, what it means is you write it in this form, 1 over 2 squared. Once I have these, what do I have? 7 points. I can go about plotting them, and here's what that would look like. The point 3, 8, 2, 4, 1, 2, 0, 1, negative 1, 1/2. Oh, I'm sorry, I left the negatives off here. Negative 2, 1/4. You see what's happening is we're getting really, really close to the axis there, but we're never going to actually cross the axis. It's very hard to draw it accurately. So I apologize that I don't have a better drawing ability here with this pen. Let me use a thicker font here, and it sometimes looks, at least looks a little nicer. So when I graph it, it's going to look something like this. But it gets closer and closer and closer to the axis here. If you look in your textbook, they have some computer generated sketches, and you'd be able to see even better how those look. So I hope that these examples have helped you. If you have questions, you're not left out on your own. Please come see me during the virtual office time, or send me an email. I'd be happy to help you that way. Or if you're on a My Math Lab homework problem, hit the Ask My Instructor and I'll send you some help that way also. But thanks for taking time for this video, and I hope you have found it helpful.